Okay, so in this one we've got 3x squared minus 10, and we have to find, on the top, we have to find a, b, and c. So clearly when we expand, a is going to be the only coefficient of x squared on the right hand side, and on the left the coefficient of x squared is 3. So using the coefficient of x squared, we have a being equal to 3. All right, we can then maybe sub in. So for example, let's go for x equals 2. So if we sub in x equals 2, on the left hand side we can get 2 squared is 4, 3 is 12, minus 10 is 2. X equals 2 would get rid of our a, get rid of our b, so we've got c equals 2. Let's try x equals 3, because 3 minus 2 is 1, so it gives us something nice. 3 squared is 9, 3 is 27, minus 10 is 17 on the left. So now we've got on the right, we've got a 1 squared times a, we've got a 1 times b, and we've just got c by itself. So a plus b plus c, where a is 3 and c is 2. So take away 5 and we get b is 12. Alright, so let's put that in now. So our new integral is going to be equal to a, which is 3 dx, plus b on x minus 2, and c, we've got x minus 2 to the negative 2 dx. The pen stopped working. Alright, so when we integrate we get 3x for the first one. The second one we've got 12 log x minus 2. And the last one, we're adding 1 to the power, so we get negative 1, and we're dividing by negative 1. So now we've got a negative 2, and the power is now negative 1, which brings it down here. Don't forget plus c. So that would be your answer for that one. Alright, we're doing a similar thing for part B. So let's have a look at part B. First of all, we've got to find the integers a, b, c, and d, and so you can see it here. You've written it over here. Okay, so in order to find that out, we can also do coefficients, and we can also sub in. We can do a number of things. So for example, if I do put x equals 2, let's try where x equals 2. Okay. As best as we can, where x equals 2 on the left hand side, we've got 6 plus 7, so we've got 13. X equals 2 gets rid of our a, gets rid of our b, gets rid of our c, and all we've got left is for the d, so 2 minus 1 all squared d. So d is 13. Alright, what about x equals 1, because that gets rid of our other bracket. So on the left hand side, 7 and 3 is 10. On the right hand side, the a disappears because of the x equals 1. The c disappears, the d disappears, so all we've got is b. And we've got 1 minus 2 is negative 1, all squared is 1. So b equals 10. We could do, let's try the coefficient of x cubed. Is a nice one because we've got no x cubed on the left, and the only x cubes we're going to get come from the a. So we've got a times x squared, and the c times x squared times x. So we know a equals negative c, or 0 equals a plus c. Alright, let's try something else. What about x equals 0? If we put x equals 0 in, we get 7 equals, so sub 0 into those brackets, you get minus 4a, you'll get a plus 4b, minus 2c, and a plus d. We know that 4b's gives us 40, and d is 13. So if we put the 4a and the 2c on this side, we get 46 Let's go 2a plus c. Let's halve everything and get 23. All right, so let's just go back above, and we've got our a plus c is 0 from the coefficient of x cubed. So if we subtract, we get a is 23, and therefore c must be negative 23. So we've got all our coefficients. Let's have a look at the integral now. So we're integrating a on x minus 1, b, this one's x minus 1 to the minus 2. Just thinking about how we're going to integrate them. This one looks like it will be a log. And the last one, let me just move that down a bit. So d, and this one will be to the power of minus 2. Okay, so this one we've got log. This one, add 1 to the power, you're going to get negative 1. So that is going to become a negative. So negative 10 and the negative 1. So it's going to be x minus 1 on the bottom. Minus 23, that'll be a log. And this one also will become a negative and a minus 1 on the bottom. So that is your solution for that. If you want, you could put those logs together because they've both got 23 out the front as well. So you've got x minus 1 on x minus 2, just using your log laws. So you could always do that as well.